4 to 5 years of on-the-job training, 4,800 hours of hot work, and then you have to be signed off on someone that you work with that says you can do the job. What we use to do hot work is a rubber glove covered in a leather protector. This glove right here is our lifeline. John don't borrow mine, I don't borrow his. A little pinhole will show you in this demonstration what I do. So we have these rubber gloves and these sleeves. These rubber sleeves, as you can see, they got on right there. They're for incidental contact. The only thing we can actually work on is with these gloves. And we have to work below the orange cuff, so we're limited to right here. You'll see as we're going in how important that is during this demonstration. A little bit about this trailer that we built here. What we're doing on this trailer is we're taking voltage off this generator over here, taking 240 volts, bringing it into this transformer on the front right here, 1099-65. Bringing 240 volts in, we're stepping it up through that transformer to that top line to 7,000 volts. Okay? So at that point, it becomes a dangerous electricity. Then it goes through that right there, all the way to the other side, and then we step it back down another transformer back there to 12240, so we can operate a street light and do some stuff for some demonstration purposes. With that being said, on the trailer you can't really see because it's bright. We would like to have been inside somewhere, it works a lot better, but there's a green light and a red light on the front of the trailer. That lets us know that there's source power to it when the green light's on. The red light lets them know that it's energized. And at the very end down here there's a street light. That'll let you all know that there's power going through it during the show. John's going to show you what voltage is actually up here. We don't want to let y'all think that we're trying to trick you or anything. So we've got a voltmeter here. We'll show you that there's actually primary voltage up there. Be about 7,000 volts. Might be hard to see today because of the sun, but there's a digital readout on it. So the trailer's hot, and we're about 6,500 volts. All right. So now we're going to show you what it would look like if you dug into a primary underground cable. They're going to hook up an underground riser into this green box over here. John's going to dig into it with a shovel. Now I want to tell you on this trailer, everything on this trailer started at 0 amps, right? So a normal line is anywhere from 50 to 75 amps. So what you see here is on the very, very low end of the scale. We have to do that to make it safe. So Kevin has hooked up the underground riser going to the green box. We'll energize it and John will put the shovel in. The arc will take place in that green box over there. The trailer's hot. So that's what a primary arc looks like at 0 amps. Doesn't look like very much, but it's enough to kill you right there. Again, if this was out in the real world, that arc right there would be blowing dirt out of it. It'd be very dangerous. You wouldn't survive it if you're on into that shovel. So they'll hook under the underground there, and we'll go back. How many of you have heard a loud boom at your house and the power went out, right? Transformer blow? That's what most people think, but it's not the transformer. It's the fuse. The fuse is that barrel out up there. You'll notice here in a minute whenever he does this, it's going to blow. This right here is a fuse barrel or a cutout or a door. There's a fuse in here that's designed to protect the equipment. So I'll energize the trailer. John will short it out and it'll blow. Now this sometimes is loud, so if you have sensitive hearing, you may want to plug your ears. Hopefully there's no MPs or anybody's going to take us away. Trailer's hot.
Wow.
That's a 1 amp fuse. All right. On our system, we have 100 amp fuses. So if I'm up in the bucket working and the squirrel climbs up on the pole, takes that out, I'm going to need one or two things. I'm either going to need someone to do CPR or a bucket to empty out the bucket, okay? We've got this bucket set up right here just so that we could show you. They wouldn't let us take it up any higher. We're afraid the airplanes will fly into it. That thing will go 55 feet straight up. And we'll work off the back. That's what we work out of. It's all rated for electricity. You can see that it's all fiberglass. It's not very clean. The guy that actually runs that truck is probably not doing very good maintenance on it. But that's what we work out of. That's the platform. The other thing we work out of is our feet. We have to climb poles. So now we're going to show you conductive material. Mylar balloon. How many of you's got kids? You bought them Mylar balloons for them, ain't you? I appreciate it because you've got me a lot of money over the years, I'm sure. Even if you were in Texas, more than likely they'd come here and land it on the power lines. So we'll show you how conductive old SpongeBob here is. He'll bridge that cutout. You'll notice the street light will light up down there, and you'll see the electricity running around that balloon. Everything's good. Color's hot. You can hear that electricity going. Of course, the wind's fighting me. See the street light coming on. That electrical field, it always hits his mic. What about kites? It's been a pretty good day to fly a kite today. We've got a kite string here. How many thinks it's conductive? We'll bridge the same cutout. Watch the street light. It's going to be kind of hard to see the arc on the kite string, but you might be able to see it. Trailer's hot. You just barely can hear it. You can hear that arc in there. It's kind of hard to see that light, but I promise you that light's working. So that thing's taking that 7,000 volts and running it through there to energize that transformer. So now we'll show you just a pine tree. We cut just a limb off of a pine tree before we come down here. We'll show you how conductive this wood is. Again, we're just showing you what's conductive. So it's hot. You can see the light burning there. It's kind of hard because it's so bright out here. I apologize for that. You can hear the arcing take place. We do that right there to let people know that if the tree is on the line coming to the ground, all that energy is going to that ground. When you walk up to it, you're walking into step potential. We'll talk about that a little bit more here in a minute. But a lot of people will go up and they think, well, that thing's not doing anything, so get a chainsaw and cut it. And they bridge that cutout there, and that gap, when it falls, all that electricity arcs right there and it goes to the ground. A lot of people get electrocuted for that reason. So aluminum ladder. Everybody's got aluminum ladder, I'm sure. Carry it like this, hit the power line, right? We'll show you, this is going to be a little bit of a primary arc on top. The wind's blowing, so it's not going to be very big. But we'll show you what that primary arc would look like if you come into contact with the primary line. So it's hot. You know, the wind is extinguishing it very, very quickly, as you can see. Normally that thing would just build and build and build and build. But when the wind's like this, it's going to blow that flame out just like a candle. So what about swimming pool? How many have above ground swimming pools? Anybody know anybody? They know the power lines, do it. Most people put them underneath the power lines because it's a nice level ground spot, right? You get to clean that pool and they run in and make a contact with them and they get electrocuted. So we'll show you how conductive this pool skimmer and sweep pole here is. So it's hot. Again, 0 amps is what we're starting with. So in the actual field, it's going to be a lot worse. This is also a single phase line construction, which means there's only one power line on top. Normally there's 3. So here we're 7,620 volts roughly, phase to ground. Normally there would be 3 lines there, and that would be 14,000 volts between them, so it'd be even amped up even more. Fire hose, we do this for fire department. A lot of them don't think that a fire hose is conductive. It'll happen down here at the bottom on the plate. It might be a little hard for some of you to see, but all the arcing will take place down at the bottom. We'll show you how conductive just a regular fire hose is wet. Because it's hot. As you can see, it's starting to track there. That's what it would look like. There's a couple different things that could happen in that instance. A ladder truck could be up, rotated into a power line, and that thing's going to go all the way down the fire hose. The guy's going to be on the end of it. Power line could fall on the ground, hit to that right there. It's like every other wreck scene. Whenever the road's shut down, there's one guy that can squeeze between the pole and the fire truck. Unfortunately, the truck's bigger than the area, so he ends up breaking the fire pole down on top of everything. So now we're going to use a fireman's boot. This was a perfectly good fireman's boot when we got it. We stuck a screw in the bottom of it. This fireman's boot has a steel plate from the tip of the toes to the heels to keep them from stepping on nails in their fires, right? So we show this right here because there's a lot of firemen that think that because that boot is electrical rating that it's not any problem. So the arc again will happen on the bottom of the plate. You'll be able to see this a little bit better. As Kevin gets a hold of it there, the wind's pushed him around. You ready? Color's hot. Again, as linemen, we never want to see these arcs. If we see this right here, we have screwed up, period. I mean, it's just that simple. Someone's going to get hurt. That flame right there on a normal day, whatever the ambient temperature is going to go up to about 30,000 degrees that quick. So that's the reason we wear all this FR. See them, they got it all on. Everything we have is that way, 100% cotton, all the way down to everything. There's no silk boxers that any lineman wear, I promise you. Nobody wants them burnt through them. Plus, they're just not as easy to clean out as that cotton.
Yeah. Beaker.
Yeah.
So now we're going to do the old dump truck. This right here is a wired down situation. The scenario we'll put this at is this guy right here was emptying his load, didn't drop his bucket or his bed before he got to the end of the road, pulled the power line down, and the power line's going to be there. We're going to show you that this truck will contain that full 6,500 volts, if that's what it is right now, at the truck. It will not arc or anything until something interrupts it. So this is a touch potential. So when you run into a wreck scene, you don't want to just run up. You want to make sure there's no power lines down or anything. So what we've got here is we got a Superman. He's going to come in and save the day. We're going to show some voltage here first. We'll get the meter out right here, and we'll show you that truck, we're not pulling any tricks again, that there is full voltage on that truck sitting there. So it's hot. See the lights on. You hear the meter beeping. I can't see what it says, but it's okay. There you go. So I'll let him get out of the way, and John will get ready. The guy's screaming wanting out. Superman's going to come in. So that's touch potential, right? You reach up, you touch something that's energized, you can't get away from it. Again, we're at 7,000 volts. Again, at that 0 amperage. Remember, this is very, very, very small. We have to do that for safety. So now we're going to show you a wire down simulation. These wires that we're using are insulated, okay? If you notice that this aluminum wire on top is not. About 90% of the power lines are not insulated. We're using these insulated wires because if we didn't, that arc that you see would work its way all the way back to the top. It'd be very unsafe for these guys that's doing this demonstration. But we're going to show you that this is just a down power line. It's the same as it would be out if it was down in the grass, in some weeds, whatever, not making conductivity to the ground. He'll take it and rub it around there and show you that it doesn't do anything to it, finds its grounding point, and you'll see the arc as well. It's rather hot. You can see it does absolutely nothing. It's isolated from the ground. And then he'll roll it around, it finds its ground, and there's your arc. And again, you see that wind blowing that thing out. If it wasn't for the wind, I would have to physically kill it right here. So now we're going to talk about a rubber glove. Again, I don't know, y'all got that down here in the middle of everything, but these rubber gloves, we test these things. We do an air test. We roll them up. We listen for air leaks because it's our lifeline. We hear a little pinhole, we gotta get another glove. We also check them for cracking. And this glove is made up of 2 colors, as you can see. It's yellow and black. 20% of it is black, 80% of it's yellow. So when that 20% wears, it's gone. The protector is just what it says it is. It's designed to protect this glove, not me, the glove. So we're going to show you here with the protector that it doesn't do anything. All we've got is just a plain leather protector there. We're going to show you that it doesn't do anything to protect if you were doing that. A lot of people think because they see these gloves on the end of us that they can get a pair of leather gloves and go work on power lines. We'll show you that it's not the case. So it's hot. I won't put the fire out. So now we got a rubber glove, which is what we work with. All right, they've got a good glove here. They're going to stick it on there. We'll rub it around there and show you that that glove's good. And then when we get done with that, they're going to take and poke a hole in it. We'll show you how quick it finds that ground through that hole, and how important it is for us to do our test every time before we use our gloves. Because it's hot. You see it's not doing anything. They'll poke a hole in it over there. Kevin will get his knife out. There's no tricks. He's just going to poke a little bitty hole in it. Just we wear these when we climb the pole. We work on them, reach over, touch a steeple. That wire, you can see how it's frayed up there. It can poke a hole in it. Anytime we suspect that we've done something, we take them off and test it. We do the air test. So we'll show you how quick it finds that ground because it's hot. You see it didn't take no time at all. That was just a little old bitty pinhole. Of course, it burns the glove. Watch out for the rubber flying through the air there. Don't let me bring that in. So again, we test these every time before we put them on. We pull them out of the bag. You see their bags hanging over there. They're stuck down in there. We pull them out. We test them before we put them on. Try them. Who's got some? Did anybody bring any hot dog buns? No one got the forward on that. We use a hot dog because it's the closest thing to a digit. Everybody knows what a digit is, right?
Yeah.
Finger. It's got a lot of fat, gristle, salt, everything that's in your skin. So we use it. You watch the hot dog, how quick it takes the load here, what happens to it. You ready? Because it's hot. Go one more time. Still hot. All right, now we'll pass this thing around. Y'all want it? Don't take a bite of it because it's going to have aluminum metal in it. The reason we do this is because we want to show everybody how it cooks. It cooks from the inside out. It's like a microwave. You can see right here's where he made his contact and the ground was in here. I promise you this hot dog's completely cooked inside. Anybody that's ever cooked one for their kid and had to skin it out, you can see how it's all cooked. This is what it does to your skin. It's what electricity does. It doesn't run on the outside of your skin. It runs on the inside of your skin, and the meat, the fat, the bone marrow, all that. Where on the wire, it runs outside the wire. It doesn't go inside the wire. So all that right here, and anybody that wants to see it, more than welcome. It is a little warm, as I say. Who's got a generator at home? The power's out for 4 or 5 days. If you're like my house, my wife's usually mad. I gotta get that thing on. If I'm at work, usually my brother-in-law's come over and try. So now we're gonna backfeed this whole system, just like we were doing over here, off that little small generator. This is what kills linemen right here. The reason it kills linemen is we go out, the power's been off, the power lines are down, it's running, it's hot. We reach and grab a hold of it without our protective stuff on because we've been up for about 4 or 5 days, I ain't sleep. That's what gets killed. So what we do whenever we go out, we have to put grounds on, of course. We test the lines with ground. We hear a generator running, we're going to put a ground on it, we're going to kill your generator. We're going to burn that generator to the ground if we can't get to it. I'm just going to tell you right now, it's going to happen. So we'll show you here that there's nothing up there, and then John will actually fire that up. You'll see that the voltage is there. Okay. I'm not doing anything. Have to close the barrel here. How much load on it? What's that little generator putting on? That's hard to believe that that little thing's doing that. The reason it does that is because it's only energized one side of the pool, so it's 120 volts before it's not balanced. Well, we got one more demonstration right here. And what it is this meter can right here. The meter's not in it because if we did, it'd be all the way over there somewhere when we get done with the demonstration. So people, mainly electricians, not to be full meters. We don't have that much problem what we used to. The clips that are in there, you can see those little silver pieces in those plastic. The older ones are porcelain. And then there's rubber. You grab a meter and that comes out with the secondary fault is a whole lot worse than this primary. Again, we've had to downsize this. We got a little small fuse in there. It's going to blow. It's going to be a little loud for sensitive hearing. There'll be some smoke and fire right there. So as soon as I energize it, as soon as they give me a close here on my solid blade.
Who did that?
I don't know. But I did catch it this time. Anyway, what happens is you pull that out and that comes in the ground and it blows right there. There's a lot of concussion there. The glass meters blow up. You get glass in you. You're with it for the rest of your life. So again, right inside the can right there, you can see everything happening. And I'll do it on 3. So 1, 2, 3. And again, that's just very, very small. I'd love to make it like it would be in real life, but if I did, there'd be parts of that can laying out in there somewhere. So at this time, that concludes our demonstration. We'll be more than glad to answer any questions y'all have.
Awesome.